Hi my friends, today we model this part. You see there are some holes, but it is not so difficult. The source is from Timoteo Carrera Soto. This is the assembly and this is our part. You see there is a hole, a sloped hole here, which has no dimensions, no positioning. We'll try to apply good dimensions. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. This is my drawing, and you see here diameter of 2 millimeters, distance of 1.5 from this center to the end of the hole, the depth of this hole, and also this 5.5 distance from the center. Let's start. Standard millimeters IPT and XY plane. We draw a vertical line with a length of 74. We make this line as a center line and we draw lines from the center point to the left, somewhere here, down, horizontal, again, back, and close. Dimensions 26, 26, 25, 17.5, 20. This is 4 millimeters. 4. This is 14. And this is 22. Fully constrained, yes? Finish, revolve. We have the first volume. Now, if you take a look to the drawing, you see metric 20 with a pitch of 1.5. Since we place here diameter of 20, the problem is very easily to solve. Thread this face, isometric profile metric 20, and the pitch 1.5. Okay, this edge with chamfer 1. Good. Now we see that there is a block here at a distance of 3 millimeters from up. The face is this one with dimensions. We apply plane, -3 for a new sketch with X to the right. Then we place a rectangle with dimensions 42, tab 26. F7, we place on the same horizontal this point with the midpoint and distance of 18. Finish sketch, extrude the other direction of 35. I hide the plane, visibility, and I apply not fillet but chamfer of 4.5 to all the 4 corners. Okay. Next is this internal hollow revolving contour with all dimensions. I start by placing this metric 22 at a depth of 9, then the contour with the dimensions. Hole this face, this center, thread, isometric profile with the diameter of 22, pitch of 1.5, the end is flat, full depth is the thread, and this is 9. Okay, we use XY plane for a new sketch. F7, we have this line, let's project it, and we draw a vertical line from this midpoint to this midpoint. This is the axis. Then I draw lines, one short line down, sloped, long right, and to the bottom, back to the axis. Dimensions. This is 4 millimeters. Next is 13. This is 2 millimeters. And we have to identify this point with this midpoint. I project this face in order to place this point on the face. Here is 2 millimeters only distance, and diameter starting from down are 4 millimeters, 8 here, 17 is this, and 22 the last one. We have a fully constrained sketch, my friends. Yes, Professor, we have. Good. Then we apply revolve with cut. Everything is defined here. Okay, you see how is the definition. Now we focus on these holes. You see both are 12 millimeters depth. This is metric 8, this is metric 14. 2 millimeters to inside and 3 millimeters on this 4 millimeters with flat end. All are with flat end. Placing 10 millimeters from up, 19 down. I select this face. I draw a line of 19. I draw a line. I place it coincident with this point. Dimensions from up to here is 10 and the line is 19. Fully constrained sketch. Okay. Then hole on this point. Threaded, but not 22, 8. 8 is here. What is the depth? 12. You see this flat end. You see full depth for the thread, and 12 is the depth. Okay. We place here the other hole, this face, this center, not threaded. This is not important now. And the depth is 2. We'll select the surface. The surface is this. And the diameter is 2 millimeters. Okay. Now you see that hole. I open this sketch. I make it visible. And I place another hole on this point, threaded, isometric profile, not metric 8, but metric 14, pitch, normal pitch, 2 millimeters. And with a flat end on a distance of 12 again. Okay. I hide the sketch. You see it was shared when I opened it to see was here. When I used it in this point, it was shared for the next all other features. I hide this sketch, and you see this one was already hidden because they are absolutely identical. Now I apply the other hole, this face, this center, not threaded. The depth, the diameter is 3 and the depth is 4. Okay. Now let's see what about this sloped hole. Diameter is 2 and you see this 1.5 distance from the end of the last hole and the other of 5.5 from the center. Let's see how to do. We cannot use an axis and a point because in this case the hole will be so, which means this material is not lost. It is present here. So we have to apply revolve. We use this XY plane, F7. We draw a line from a point, an arbitrary point, to an arbitrary outside point. We project this line and also this line. We use the horizontal constraint to place this point aligned with this center line. All I want is to have this point outside the material. The distance, as I said, is 4 millimeters. From this point I have to place here a point on this and coincidence with the line. The distance from the point to this face is 4 millimeters. Wrong. 4 millimeters is the depth. Here is 1.5. Excuse me. Here the same situation. I project this line. I place a point on this and I make coincident this point with this line. The distance is 5.5 from the center, from this point. 5.5. Good. This point is outside the face, the material, so that we don't care where it is placed. We have one dimension needed because I don't place here a dimension. If you want, I can place, no problem, to have a fully constrained sketch. For instance, 2 millimeters. Then we use this rectangle in 3 points. One is this, another is this, and the distance is to be added. Yes. Why? Because I make this center line, and I apply diameter here of 2 millimeters. You see, both ends are outside the material. Finish sketch, revolve. I have these lines and up the upper one. I didn't place here construction, and I need to select all these 3 segments. Select axis, this is known. The option is cut, OK. I select this face to be used by applying set current view as home, fit to view. It is outside our screen, but you understand what I make here. We finished the part. Let's see what is the volume of this part. Properties, physical, update, copy, close, drawing, double click, paste. Oh, there is a great difference. This is the difference. No problem. We eliminate the former value with the present value. We go to the part, we apply material, which is steel carbon, and that's all for today. Thanks for watching. Bye bye.